Hello.
Lecture number 5, nomenclature of alkenes and alkynes, the unsaturated hydrocarbons.
Yeah, double bonds and triple bonds today. Yeah. So basically there's a double and a triple bond, use up bonds from carbon to carbon, reducing the number of hydrogens that can attach to this hydrocarbon. And now I am now unsaturated.
So if two carbon atoms are connected multiple times, that's spots that would have been for hydrogens that are no longer used for hydrogens. So that's why it's unsaturated. It isn't full of all the hydrogens that it could be.
Correct.
To name alkenes, we'll have a double bond. We have to number up our hydrocarbon chain, okay? And Mr. Milks is going to number in 2 directions, because the rule that is going to come into play is that we have to use the numbering system, right to left or left to right, that puts the important part of the molecule, in this case the double bond, with the lowest number. You'll see that in a minute. So count the prefix for the carbons. There's 5 carbons. It tells us we got to use the prefix pent. So he's going to write in the word pent. So the prefix of this molecule is going to be pent. Now we have to decide, is it ane, ene, or ine? Now the root tells us what kinds of bonds are present. So table Q shows up, and we see that, oh, look, there's a carbon-carbon double bond going on in there, which makes it an alkene type hydrocarbon, which means that the end of our name, the suffix, has to be ene, E-N, ene. But wait, there's one little piece more. We have to put a number out front to tell us where the double bond is, the address for the double bond. And the naming and the addressing system is that we have to put it with the lowest number possible. So, as you can see, Mr. Milks was counting with green dots. If you count from left to right, you'd say this was 3-pentene.
Correct.
But if you count from right to left, you would say this is 2-pentene.
Correct.
And the post office, IUPAC, tells us that we have to use the lower number for the address. While 3-pentene and 2-pentene might seem to be the identical molecules, and they are, it's the nomenclature naming convention that says you use the lowest number possible to make things simpler. And that's going to require you to count your hydrocarbon chains in both directions
in order to figure out where there is a deviation from a regular alkane.
Right.
And that's really what the game is now. So we did the alkanes last video, and then in this particular video, we see that there's just a slight variation. There's that double bond in there. So how do we tell you that there's a double bond in there? We end it with ene. Then you got to tell me where the double bond is, so that I could go backwards from this 2-pentene and draw it. And the reason why we can count both ways is we can just take this molecule, and when you're playing with these in real three dimensions, you can see it. You can just flip it.
Is this really a different phone?
No.
Molecules do the same thing. They rotate in 3-dimensional space.
So that's why we got to count them both ways so we know which way to go.
Exactly.
Good.
So let's do some alkynes. The same exact pattern, except that we have a triple bond in play. So we're going to find out the carbons. Number up both directions, left to right, right to left. We got 5 carbons, which means that we're going to have pent as our root. Now we have to decide, is it an ane, an ene, or an ine, table Q. So Mr. Milk sees there's a triple bond between carbons, which matches the triple bond in the alkyne series. So now we know how to end our hydrocarbon's name in Y and E. Now we have to figure out where to put the address for that triple bond. Do we put it on 1, 2, or do we put it on 1, 2, 3? Which one is it, Mr. Milks? Should we go with the bigger number or the smaller number?
The smaller number is convention.
Right. Now, while 3-pentyne is technically identical to 2-pentyne, 2-pentyne is the proper way to name it using the rules. Okay. So let's see. How do you quickly recognize alkane and alkene type hydrocarbons? Why is that disappearing? General formula from table Q. So alkenes and alkynes will have double or triple bonds. So they're going to look like this. So alkanes are CnH2n plus 2.
That is in our reference table.
Alkene
is CnH2n.
And alkyne
is CnH2n
I remember CnH2n minus 2.
2N minus 2.
Yeah.
There you go.
So if you have just a generic hydrocarbon and you're not sure if it's an alkane, an alkene, and an alkyne, you count the carbons first like you always do.
Yep.
Then you apply one of these three formulas from table Q and see
Do the number of H's match up?
if I'm using the number N for the carbon. So for example, if I just want to do
6 carbons.
right, I'm gonna
sorry.
throw a hydrocarbon out here.
Okay.
C10H22. Which
Okay.
one does it belong to, Mr. Milks?
Well, I see that it's 10 carbons, so I'm going to use 10 as my N, right? So now I got to figure out the H's because I already, all right, right? So I wanted to just know H's. So 22, I go 10 times 2 plus 2 is 22. I got lucky on the first try.
For sure.
Because if I had 10 carbons, let's just do the whole thing. If I had 10 carbons, how many hydrogens would the alkenes have?
Well,
It would be 2 times 10, which is 20.
20.
So it would be C10H20.
yeah. Oh, you want me to do
Yeah,
that?
yeah,
Alkene, I got you. So
And then the alkyne of that same form of number of carbons would have 2 less, so it'd be H18.
18.
So as I add more bonds for carbon in between the carbons, I have less room for hydrogens, and you see how the number of hydrogens changes with the same number of carbons. So that's I think what we're trying to show.
that's how you can quickly, just from the molecular formula, tell alkane, alkene, alkyne. So
We
let's
got a few examples.
yeah. Let's
Ready? So ethene, I see first off, eth tells me how many carbons. Eth is 2. And then ene tells me there's a double bond. I only got one place to put it. Fill in hydrogen bonds or hydrogen atoms, but carbon can only have 4 bonds. And if you see the way Monaco put them in there, each carbon has 4 bonds. You've got to be able to count those up. Prop. Prop is 3. Double checking. Prop is 3 carbons. Okay. Ene automatically by convention goes on the first carbon. We don't say 1 propene. We don't put the 1 in chemistry like that,
Because if you pick that up and rotate it like we did our
It'd be on-
phone,
it'd
it'd
be
be
on
on
the
the
other
other side. It'd still be one.
right? So molecular formula, C3H6, and is of course unsaturated. Bute is 4, right? I'm using table P to see that. And it says 1 butene, which tells me that the double bond is on the first carbon. Here I have to tell you because it could be on carbon 2. Okay? And then the molecular formula again will change. And the number of carbons goes up, hence the number of hydrogens goes up. Now this one we got to go backwards and name it. So I have 1, 2, 3,
Oops, I
4.
messed up my numbering.
Yep. 1, 2, 3, 4 carbons. So I know I'm going to start with a bute. Okay. I see a double bond present. So on table Q, double bonds is an alkene. So it ends in ene. Now we got to tell us where it is. And it is on the
Third carbon, no, which,
Ooh.
or is it the second? Or
second carbon.
Ha got him.
He went across this way on the top. Yeah, see? So the lowest number would actually be 2. It's on the second carbon either way you go in this case. So, which makes sense because if I flipped it, it wouldn't really look any different.
But
Okay.
2 butene and 2 butene are not the same thing, are they?
But there would be no such thing as 3 butene because then that would actually go back to 1 butene. Right? So then we're unsaturated and we is good. No. Oh, quick ynes. Quick ynes. All right. Same process. F tells me how many carbons. I see it's 2. Triple bond lowers the number of hydrogens because now there's 4 bonds around each carbon. If you were to circle them up. Prop tells me right off the bat 3. 3 carbons, 1 propyne. If I put the triple bond on the other side, it would still be 1 propyne. So on F's and props, we don't need to put that number in front, but we will see with the butes that we do because bute is 4. So now there is 2 places where this could go. And it says 1 butyne, so I put it on the first carbon, fill in my hydrogens. Yes, you need to fill in all of your hydrogens with dashes, just like Monaco's doing. And now this last one, I need to come up with a name. So we're going to go backwards. 1, 2, 3, 4 carbons is a bute again.
Yep.
And I see a triple bond. So using table Q, I see the triple bond is an alkyne with a Y. And either way I count, it's 2 butyne.
Yeah, straight chain. You got to count your carbons, you got to count your double bonds, and you got to figure out where they belong.
Yeah, I like the address method. Really
The
helps.
address method really helps.
Hey, practice.
Thanks for watching, everybody.